All right. So, we are going to be in this particular lecture continuing from what we had done before, that is talking about the techniques, the principles involved in producing stretch yarns. Now, we go further and we go and check the principles involved in the manufacture of the textured yarns, maybe on the modified stretch yarn. And so, if you recall, we had talked about stretch yarns which can be produced by Helenka process, which is a batch process, but it gives you a helical structure because we are using twist. Then there is a false twist process, the twist is still being imparted, but in a manner which is slightly different. This also gives you a helical structure. Edge crimping is also a different process, does not have a twisting mechanism, but still it gives you a helical structure. And the turbodue has a twist, but without a twister, it also gives you a helical structure. So, all these processes which actually have produced stretch yarns had helical structures. So, we go to the next step, which is the producing the modified stretch yarns. And what we said basically is that for every application we would not require a large amount of stretch, and therefore, we would reduce the stretch, and therefore, the name modified, because first you produce a stretch yarn and then modify this yarn to get to another thing, which is what we call as a modified stretch yarn. So, this is what we start, and hopefully, we will be able to continue and finish this particular requirement. So, the requirement of a stretch yarn, as we have said, is reduce the stretch by to the extent, let us say we reduce it to 100% to 150% stretch. And the technique that we will see is something like that. The same process which has been used for producing stretch yarn, Helenka process, which we understand is a batch process, can be used to produce modified stretch yarns as well. So, we have principally first twisting, then we do setting. So, some type of a set, and then detwist, this was our original process which was producing a textured yarn. So, now we said that after this detwisting we are producing a soft package. We tried to understand that soft package means the density of the package is less, that means the tension during winding has been less, and after that we say another setting treatment, and then we say we will get a modified textured yarn, modified stretch yarn. So, the question that needs to be answered is as to what have we done. We did say that the temperature requirement for the second setting may be different, and different in the sense that, we are assuming here that we are dealing with, let us say, thermoplastic yarn. If we do use a thermoplastic yarn, then temperature is the means, the heat is the means with which you can set. So, you will have certain temperature. So, whatever temperature that you set up at the first heating cycle, in the next one you will take less than that temperature. So, all the things that have been done before are not going to be washed off. The memory will still remain, but something will happen. So, what happens actually? Just because we have made a soft package and just because we have tried to reheat it, what exactly has happened in this process? And we are also saying it remembers the previous memory also. How does the stretch get reduced? So, the trick is, one is a soft package and the other is lower setting temperature. If suppose the tension was very high during winding, we had seen the stress strain curve that a stretch yarn has a lot of extension, which is we call a stress, at a very low stress, very low stress. That means, the winding tension, if is above this value, you will have a flat yarn. That is, when you wind, it will be just like a flat yarn. It requires that much stress only to ensure that all the crimps are gone. So, if you have winding tension like normal winding tension, which we call as a right density package, we will get fully stretched yarn while it is on the package. If you do not heat, then there is no problem, it is just stored and you can use it. After unwinding, it will start giving you the stretch, it will start getting into the memory and give you the helical structure. But what are we doing now? Maybe during the winding process, we are making soft package, tension is less than the winding tension, and so there is a possibility that it is not fully stretched. Let us say I have, this is a situation of my stretch yarn. I pull, let us say I pull only downwards, then we will get extended length. If we have more tension, maybe we get fully extended yarn. When we have more winding tension, then we would be winding a yarn like this. If we have less winding tension, maybe we will be winding a yarn like this. Is that okay? Can you see that? Right? And if we have no tension at all, then we would be looking at a yarn in this shape. So, if I reduce the tension or make to 0 to such an extent that this is the state which is there. Now, how do we measure stretch? Let us say approximately, I will try to extend it to full length and then I will allow it to recover, and when it recovers it will go back to this state. So, if I do not put any tension, then this is the shape in which I will be reheating. If I put full tension, then this is the shape in which I will be reheating, and if I put some tension which is different than these two values, then my yarn would have been extended partially. So, limited extension. And what I do? I do limited extension. By making a soft package, I have reduced the tension, but not to the 0 level. So, it will be partially stretched, not fully stretched, while it is being wound. Okay. So, you control here. So, you control your tension, winding tension, this will be controlled, and this has to be quite accurate also, because you know very small amount of stress is required to extend it further. So, within the small area of small limits that we have, we would have to be working. And then in this state, let us say in the case of thermoplastic, I reheat. So, the changes that will take place in this yarn in the reheating cycle will be in the state which is different from the original state. So, we know that in a thermoplastic yarn the setting is reversible. If you go to this higher temperature again, all the creases that you may have formed can be removed, and similarly all that you have done in the first step can also be removed, and so we do not want to remove it, we want to partially modify, and this is the process is partially modified. Now, what happens is that why this is reduced stretch? Because now the new position is this position. The new position is this position. Okay? So, this is a new position, and if I extend this further, so this can go up to this limit, because the fiber is the same, yarn is the same, which is the maximum stretch limit. And so, when I will say remove the load, it will go back to this position and not this position. You see, it will not go here, it will go up to this position. So, reduced stretch. Do you think now? So, simple trick that you wind at a lower winding tension, take it back to the autoclave at a temperature which is lower than the previous one. So, you are not wanting to wash off all the memory, but only part of it, and you get set in a new configuration, which now cannot obviously percentage wise will be able to stretch only this much, right, and so reduce stretch. So, by using a Helenka process, we are able to get modified stretch yarns, all right. How much stretch again depends on how much winding tension. Can we do something in the false twist texturing also, which is a continuous process? Just to revise, we have a feed roll, you are feeding the yarn, then you have a heater, the yarn moves over the surface of the heater, gets heated to a particular temperature, and then it gets cooled. There is a twister which is twisting, the twist flows down, the twist flows down, all right, up to the nip of the roller, feed roller, and above the twister it is getting untwisted. So, you start with a parallel bundle of filament, and theoretically you are getting out also as a parallel bundle of filament. Only thing that has happened in between is, in this region you had twisted yarn, you had a heater, and you also were able to cool it down. So, it is important that you cool it down before untwisting. Okay. So, this is how we produce stretch yarn. So, we want to do modified stretch yarn. So, now we have two heaters, one is called the primary heater, other is called the secondary heater. So, up to this point, which is the cooling part, you have same thing. I have shown some bends, the bends can be there, bends may not be there, it is a line diagram. Okay. Actual machine may be different, that depends on whatever you want, and therefore, this is a double heater machine, but it is a continuous process and we wanted it a continuous process. So, we are not making packages in between. So, it also has the primary heater, the cooling zone, and the cooling can happen in this area also without any problem, and then there is a twister. Okay. And this twister, obviously the twist flows from here in exactly the same way, it goes like then goes down all the way to the nip roller, nip of the roller. Okay. In between you have heated and cooled and now untwisting. So, in a normal case we would have withdrawn the yarn from here, but now what are we doing? We are passing it through another heater, which is called the secondary heater, and then there is another set of rollers and there is another set of rollers here, which is in between we have the secondary heater. Of course, there will be space, this also will have chance to get cooled, but and what do we remember now here? In the case of the Helenka, the temperature requirements in this heater and the temperature, let us say T1, temperature 1 versus the temperature 2. So, the temperature 2 of the secondary heater is less than the temperature of the primary heater. That is one condition which can be met. How do we meet the second condition? The second condition was, if you remember, the second condition was the soft package. So, we do not have a package here, you have a heater and it is a continuous process. At this point everything should be done, finished. So, what are we going to do? So, in this zone we will give overfeed, and what does this overfeed do? It has less tension and therefore, the yarn is not fully extended, and because the yarn is not fully extended, therefore, it is going to be set in a partially extended condition in the secondary heater, and if time, temperature, other conditions are optimum, then modification will take place. Is it clear? Anything that you have any difficulty in conceptualizing this part? No issues. And then of course, you wind.
So, the distance from the twister to the feed roll and the twister to the winder, is it approximately same?
The distance between twister to the feed roller and twister to the winder is same? No, it is not. and this, as I said, is a line diagram. The twister to the this part will depend on whatever we were doing earlier. From here to here, it will depend also on whether you have been able to heat it to the correct temperature, and then after that you would like in that condition to be cooled only. You do not want winding to also take place while it is hot. So, the distance are not same, they are going to be optimized. So, it would depend on what is the cooling mechanism, what is the heating mechanism, what type of a yarn is being used, nylon, polyester, polypropylene. All of them will require different conditions, and so this will not be same. Does that answer question? All right. So, what did we do? Overfeed. Means limited extension, you know. And reheating in this condition, and then you get a modified textured yarn. So, we are looking at principles. Okay. So, that is what we did. So, Alenka can be used to modify, false twist can be used to modify. Can we use this turbo duo process to modify? Can we use? No. So, some answer is coming here as no. Any other answer, any response? Yes. So, it is called the dichotomy. So, either you have yes or you have no. All right. Why do we think it should be no? What should we think that it cannot be done? Because every time we say yes or no, it should be backed up by some reasoning. How many people actually believe it is no? Let us put it this way. You can raise your hands. How many people believe it is no? Even the one who proposed is not raising his hand. That is okay. That is okay. So, what we are saying is there is some confusion, but why should there be confusion? Let us say what was our turbo duo process. So, our turbo duo process essentially was that you had two sets of yarn coming to a zone, and they had certain amount of twist and then they were separated. In between we said we had a heater, and you were obviously cooling also. Is this the process? Now, we want to modify this. Can we modify now or no after looking at diagram? We can. So, what do we do? Where do we put a secondary heater? It is a continuous process. So, it is a continuous process. Before winding, can we put a secondary heater somewhere here? Yes? No. Why not? The cooling is done. Right. So, there is enough tension here. You remember? These yarns are under tension, and this tension should be sufficient enough to remove the yarns from this zone. If we can remove the yarn, therefore, there is sufficient tension, and so your helical structure is not being seen here, it is a fully extended form. All right. So, what do we do? So, you got to have take up, you got to have a take up roll, and then you got to have another take up roll. In between, you can think of heater and overfeed. So, the difference is that after twisting and untwisting, this is the untwisting process. Now, you have two strands. So, you got to have a two heating cycle, two heating systems, at least both the yarns must be treated individually now, right, and then work it out, you should be able to get it, right. So, as an engineer, you can always find a solution in case you think it is principally correct. If you really think that principally it is a wrong idea, then obviously you will not find a solution. But if you believe that principally it is okay, it should be able done, I think this could be a possibility, and you would be able to get a modified stretch yarn. Make sense? Then we have the edge crimping. Before that, what will be the structure of this yarn, helical or something else? We have done nothing, so it will be still helical. So, the edge crimping, we recall the edge crimping. So, there is an edge and the yarn is being taken and there is a heating cooling cycle, let us assume. So, what do? We do not answer this. You will design a process using edge crimping technique to produce a modified stretch yarn whenever you have time, all right. So, should be possible or no? So, only design is an issue. So, everybody should worry about their own design, just design it and put in a notebook, you do not have to report to anyone, we will find out sometimes. So, if you summarize, we have modified stretch yarn being produced by all the four methods. One is called the Helenka multi-step process, other is false twist texturing, edge crimping, turbo duo twist, and all of them still give us the helical structure. So, while it is an interesting thing to note that the stretch yarns do have helical structure, even modified stretch yarns can have helical structure. How much they will stretch depends on what have you done to them. So, it is not that just because there is a helical structure, therefore, it will give you the maximum stretch. No, you can reduce that also. So, the processes therefore will be modified accordingly. Where do we go further? MSY, that means modified stretch yarn. Can we use any other technique to get to the modified stretch yarn? You must remember one thing, that we say what can we do? We are expecting, the expectation is let us say reduce stretch or the stretch value less, all right. This is also a range, the range could vary also. That is, can we use any other technique, any other alternative, and that will be interesting to know, right. So, let us see what do we have. Have you heard of this term? Maybe before. Stuffer box texturing. It is a very simple thing, it looks like a box, therefore, it is a box. You stuff the yarn into this, therefore, it is called stuffer box. Finally, you get something called a textured yarn, therefore, its a process is stuffer box texturing. So, what do we have in thing? There is a feed roller. So, you have a feed roller and this pushes the yarn into a box. This is the box, all right. So, this is our box, and then there is a system with which you can, if you push it hard, this can be thrown out of the box. So, there is a wall being created by, let us say, door or a flap, which obviously under certain pressure. Let us say the pressure in this area becomes high and this pressure is low, the whole thing called a plug will be moved out, it will be thrown out. But you can change the pressure, therefore, output from the other side would not be able to just pass through, it has to strike. So, the yarn in the beginning, let us say, would just be forced and may start collecting here, then fold here, then the fold here, and so on and so forth. The yarn is getting at a particular speed. If you keep the mass balance, the yarn must also get out from the other side approximately in the same amount. If you particularly the extended mass approximately. If suppose this is also thermoplastic material, so what are we doing is, we must have some way, this is called the deformation mechanism. When you throw against a wall, the yarn bends. If the yarn is at room temperature, bending behavior will be different. If the yarn has been heated, then its bending behavior will be different, become soft. So, that is okay. That means you have a control. The pressure at this, you have a control. The speed at which you can throw the thing has a control. So, although this process is so simple, you have to do nothing, just keep throwing the yarn into the box, yarns and the filament thereof will bend, and so the crimps will be generated. So, the yarn which comes out will be something like this, which means that if you extend, it should be possible for you to extend. If you have set it correctly, then it will recover also. Okay. So, interesting part. So, interesting is very simple process, just throw something in the box, it will bend. As it bends, you heat it, set it, and after setting you can remove it under low tension, so that the crimps remain. It will get cooled, let us say there is a conveyor system, and then just collect it, wind it. Okay. Now, this principle is being used, if you have seen the staple fiber making industry, whether it is the viscose industry or the polyester or any other thing, we make staple. So, they use this technique to crimp, because very simple. Of course, the temperature requirements are different. When you use a polyester yarn or fiber which has a crimp, crimps are required, isn't it, in the fiber for spinning, to facilitate spinning, carding, etc., you require certain amount of crimp. So, natural fibers have crimp, so synthetic fibers are given the crimp. But those crimps are not supposed to be very permanent, they are just supposed to be good enough to make sure your process takes place, and after that you are not so much interested in the crimp. But when you are looking at texturing, obviously you are interested in the crimp to last, and here you are not going to be cutting them into staple, it will still remain a filament yarn. If you want to cut, no problem, but this is how it will be. So, simple process. So, says the amplitude and the frequency could be controlled by temperature and pressure. So, it is not a completely uncontrolled process, but definitely all the crimps are not of the same size. It could be randomly, but you would have an average crimp height and average amplitude and frequency. So, the structure, if somebody wants to know, is it helical? No. So, it is going to be called a planar structure. So, in this approximately just a name. So, the crimps are bending in the same plane. The yarn is bending. So, the plane remains or the bend remains the same. So, it is not really helical 3-dimensional type of structure, but very simple, is not it? Now, the range, the stretch range approximately comes in the same range as the modified stretch yarn. So, they come in the category of the modified stretch yarn, although you are not modifying, you can give whatever. So, all stuffer box textured yarns will be in the range in which the modified stretch yarns are, and one of the reason is they actually do not have helical structure also, all right. But after a few minutes we will stop, just talk something about it and then we will move further. Gear crimping. Somebody said, well, you are going to make a crimp, so why can't I use gears, the intermeshing gears to produce the crimps? Say, ki, why do you want to do that? Stuffer box was any making crimps, so why did you do that? So, the argument was that here my frequency and amplitude are in my hand completely in control. Of course, you can heat the gear, of course, you can heat the yarn and push it inside, change will take place. After that, before you put any tension, you would cool it, right, in case we are talking about thermoplastic yarn, right. Simple. Its structure will be also planar, but same. So, we will stop here today, and next time we will pick it up from here and take if there are any other methods which can also be used to produce modified stretch yarns. All right. See you later.